Hello everybody. I've just pushed out a video on why programming's easy and math's not, where I focused on such ideas as APIs and dependencies. Specifically the point that in programming, dependencies are clear. In math, dependencies are missed, turning you into not a math person. So in other words, it's local, and here it's in your past, right? So that's a really big problem. But then I went on to say how, even in programming, APIs change sometimes rather radically. But you can see why. And that makes all the difference, right? So here I didn't load anything up in preparation for this because I figured I'd do it from scratch. All this from scratch stuff is really a great way to do it. Hopefully I don't shoot myself in the foot by having anything stupid loaded by default in Jupyter Lab, like proprietary work stuff, which I would have to exit out and stop this live stream if I messed up. So I load my Jupyter Lab, which I have recently upgraded, by the way. That doesn't appear to have run. I'm going to do Control J. It's the same thing as double clicking. Oh, it's probably going to run twice. There it is, running twice. So it had very little visual feedback. Oh, no, I take that back. This one is my streaming software. This one is Jupyter Lab. Hey, there's a good way to see that I'm really streaming. I mouse over it. I can see the little audio things flickering. That's OBS. Versions are important. 27.2.4. My Jupyter Lab is also recently upgraded as of days ago. Oh, good. This is a good one. It's MLSEO that's loaded. I went through some interesting steps here. I don't want to go on too many tangents, but I do now have it so that I can load up Chrome and load all my sites by just going open all these. But I'll do the individual one for MLSEO. It's on, nope, that's my old personal site. That needs updating a lot. Oh, it's the very first one. So my library, which you can pip install MLSEO, now has its own website. The documentation that's built in on Jupyter Lab itself, see here, becomes the homepage of my website over here. I might change a template. I'm not too happy with that. It's a little bit small. But everything that's actually in this notebook here, see, right down to showing this keyboard shortcut at the bottom, is also over here. And so that's a great way of doing general development work. There's an API lesson in that, so even that's kind of relevant. But what I really want to show you is just starting a new notebook. So I very typically go into my practice directory so that I keep my various untitled whatevers in the same place. I make a new notebook and like that. And so that becomes part of that is whatever one down here. You'll see it actively loaded. If we do last modified, it should bring it right to the top. There it is. That's Untitled 6 we're in. So what I'm going to show you is shifting APIs. So I will rename this notebook to How APIs Change. Not a very Pythonic naming convention, but so what? Okay, so first of all, let's see what the slash operator does. So 1/2, right? 0.5, 1/2, that's division, right? So this represents division, and when you see that in other places, it means division as well, right? Well, not always. So if you from pathlib import path. Now before I do that, I'm going to put a box above it and say if I tried to do foo/bar error, right? foo/bar is not valid. You can't divide foo by bar. However, if you from pathlib import path, you now have a path operator, and you can say path. Maybe you can, I apparently can't. foo/bar, right? It's the same slash in that slash there as it is there. Why is this statement causing an error? And this statement, make me eat my words, unsupported. Well, the reason for that is because foo and bar themselves are still string objects. You can only do this to other path objects, so it might seem a little redundant, but what I need to do is put path around foo and path around bar, turning them each in turn into path objects. But the same lesson applies. I am dividing something by something else, which are very clearly not numeric in nature. And there you have a Windows path foo bar. So within the context of path, in fact, I probably don't even need that outer path. I could have made this example simpler there. So why does this create an error and this work, even though you can see it's outside of a path operator? And you might think it's because I ran it and I went back, so I'm going to restart from scratch. As long as I import that, this is valid, right? So I'm doing division of things that look like strings, but they're actually being turned into path objects, which make adaptations to your local operating system. I happen to be on Windows, so if I was on Mac or Linux, it would be a Unix path. And the division operator has been overwritten by the path object. Path objects are allowed to have the slash between them, and it will append them together into a larger path. So in programming, APIs can be overwritten. And you can see why. In the case of Python, you can see the import that's doing it. So if you wanted to check what these things were, you could check with a type. It is a pathlib.windowsPath object. Those are allowed to have a slash operator between them. So context matters, but then so does, context matters. Context matters. But then so does is just another way of restating that. Another example, right? That's a good one, right? But we'll get rid of all those. Restart our kernel, right? Fresh start, right? When is a good time to restart your kernel? Now is a good time to restart your kernel. It's always a good time to restart your kernel and clear all outputs. Another one is the slice operator. But before I can tell you that story, I have to tell you this story. So import random. I always forget the sub things I want to import, but it's good to always import something and then dir what you just imported so you can see what you got. You go past all the things at the top. You go past all the single and double underscore things, and you look starting at about here, and you can see all the things that are in the random thing. Now I'm just looking for, random, probably .random. See, there's random. There's also random int, which is good. Let's get a random integer, right? So now now that I know what I'm doing, I can go from random import random int. I'll do a kernel restart, so that original random import isn't there anymore, and now things just become a little bit cleaner to demonstrate. Random int. Cannot import. I did something wrong. randomint. That looks correct. Oh, I hate when I get that stuff wrong. Okay, so we'll just go back and import random. Be like Roomba. Do not get, bent out of shape on little things that you do wrong, just back up, turn, and reevaluate. I probably just visually looked too quickly. QR random randint. We're going to do that one more time. From random import randint. Okay, we still have that other thing loaded, but so what? I can use randint on its own. Randint by itself, missing two required positional arguments, A and B, from 0 to 108, right? Each time we run it, we'll get a different random integer between those two ranges. Very nice, right? So the reason I'm doing this is because I want to demonstrate the API of Pandas Slices. So just normal slices and then Pandas Slices, and show you the way the slice API is overwritten by Pandas, the way the slash operator is overwritten by pathlibs. So what we do is we make a data frame. So times 20 times 10. No. Not a list comprehension. We just want, I'll do it old school, right? So we're going to say table equals for I in range 10, row equals oh, yeah, okay. Nested, we're going to do for I in range 10 and for J in range 10. This is old school. There's definitely more elegant ways of stating this, but you know, we can just put a pass in there and just know that our code is good as a first step, but we're going to make a little data frame of just 10 by 10 random numbers of integers, right? So row equals, on your inner loop, you recreate a row, and then row dot append that. And then when you get back to the outer loop, you table dot append row. And now at the end, you're going to have a table of 100 by 100 random integers, right? Nice exercise in doing data frame stuff. It's not that much code to get there. It certainly has nothing to do with the API lesson I want to give. But once you're sitting on that, you can now import pandas as PD. Well, that's about changing the API. In that table, I can demonstrate slices. If I wanted, first, before we demonstrate slices, we can say grab the first row, right? See, that's the first row there. You can say grab the third row, which is really the fourth row. That's this one here, because zero-based indexes, right? So you can grab any row from out of there directly. But if you wanted to grab that row and the one beneath it, you just put 3:4, and now, make me eat my words. Let's see. Slice notation. Oh yeah, no, I'm right. 3 to 5, right? 3 to 6. So this is slice notation. You can take a slice out of, any list, any iterable, enumeratable object. So I am grabbing from here to here using slice notation. This is slice notation. It uses square brackets. It looks just like grabbing something with numeric-based indexes, but you put a colon between it and you can grab ranges within the numeric-based indexes. That's an API, right? So this is the default Python slice API. All right, clear enough. Are you with me? Not that much code. We can get rid of this, right? If we restart kernel and clear all output, you can really see how little code we're using. That is just to show the table. I can put that there. And so the whole thing together, and append that. That shows you that. That shows you that. Okay, that sets the stage for this and shows you that there is an API here called the Slice API that resembles the numeric index API, which is also a default API in Python. But we're going to override the use of square brackets in a slice. How do we do that? Import pandas as PD. And now we can go pd.dataframe table. Bet you didn't know turning, these types of objects into these types of objects was that simple. Or maybe you did. There's a bunch of people out there who probably do know it's that simple. And hey, high five to the club, right? Python, nice. Everything easier, everything faster in Python. Everything more natural, more flowing, more like English spoken word in your head, but better because of lack of ambiguity. In Python, tiny divergence. In Python, explicit is better than implicit. If something is being implied and you have to understand it by prior knowledge, like the math APIs, it's not Pythonic. Explicit is better because, you can see what's happening. That's why, the best example of that is 2 times 2, valid, it's 4. 2 times foo, valid, it's foo-foo. Foo times foo, blows up, it's an error. That is because of this line. Why should this one work? That looks implicit, not explicit. It's because there can be no other meaning. An integer times a string can only have this meaning because there is no conflicting conceptual space there. I'll have to make another video on that because it's a fairly nuanced point. Okay, so all that was kind of a divergent or a tangent. But so we've got now this data frame, and the most common thing to do is say df equals that. So you've got a data frame now that you can refer to the same way you can refer to the table. Here's your table. Here's your data frame. Very similar, but this has a different API. What kind of API? Well, say I wanted to grab those same rows. I forget, I grabbed like, where's that 50 something? Did it do it right? Oh, 77. Okay, yeah, it ran differently. The numbers are different because it's a different set of random numbers. So it's these that I would like to select. And to do that, you use one of the strangest, but I guess necessary. Oh, this is so, it replaced things like .ix. There were all kinds of things that you could use to do this in the past, but Pandas has been pretty much settling on df ILOC. That's an indexed location because we're going to be grabbing rows by numeric indexes. And ILOC is a function, I believe, not an indexed, a numeric index system. So you have to start out with parentheses, right? Parentheses versus square brackets is such a big issue in Python to wrap your head around. But let me first try that. Look, it might be square brackets. It is trying to be a numeric indexing thing. Let me try that with parentheses before I start telling you the wrong things. Yeah, see how it's coming back with, an indexer type thing. It's reference to the function, even if I put, I guess, let's try putting something that should break it in there. Yeah, see, that's going to break it. You can't do that. So it is square brackets. This is trying to simulate a numeric indexing system. Can't leave it blank. If you give a 0 by itself, look, that 15, 70, 69, what is that? there, 15, 70, 69. So you can see that the default is grabbing rows, which is good, because you also could very easily grab columns. Let's try that. Let's try I-lock like that, but I think you can change the axis. Can you do that in here? Axis equals 1. No, it doesn't like that. I didn't think that could go into that kind of thing because it just wouldn't make sense. X versus Y. Well, let's get the documentation up here for a second. This is, Pandas I-lock. You'll always get the standard, the real documentation as that first hit. And then you scroll down a little. You find an example. And yes, they are indeed using square brackets, so I'm on the right track. There's a simple notation for doing that. See, something, comma, in square brackets. It's like slice notation, but with a comma. So let's try reproducing what we did up here. 3:6 should in I-lock be 3:6. 46, that does not seem right. Well, I didn't think it would be right, and oh, look, double square bracket. Ah, yeah, there it is. Fun stuff. Huh, close. 77, 80, 77, 57, 60, and then the 93 is down. Oh, yeah, it's just a list. That is row 3 and row 6. Okay, so see how the APIs are changing here a bit, but now I think I'm going on too much of a tangent here. What I want to demonstrate is that when you put a colon in by itself, it's the whole same thing over again, because there are two implied positions here, upper left and lower right. What do you mean upper left and lower right? It's because there are two comma values in here. Wait, what? Maybe I have that in reverse. Colon, comma, colon. There we go. There are two implied slices in here. That comma goes between two slices. And what we're avoiding is notation like this. The Pandas people said it would be awful to make people type this many square brackets. That's invalid syntax. Although this is what would be appropriate if they were not overriding the slice API within the ILOC interface. So what is this? This is, say, from zero, 3 to 9, 5. Do I have it? Let's see if I can figure this out. Oh yeah, you don't use both sides. If you're just choosing rows, I believe it can be on the left-hand side. That would be 3 to 5, 3 to 6, 77, 50 there. Okay, 3 to 6. There it is. So there you have it. It takes a little struggling. You saw me struggling, but there's table 3:6 with the standard slice operator of the default Python slice API. It takes square brackets around the slice. And when we go down here, we're selecting rows because to the left it's rows, to the right it's columns. If I were to take that 3:6 and put it on the right hand side, so first of all, this is what, now making the point again, this is the notation we're avoiding. That won't even take it, but that would be the correct Pythonic way of doing stuff. But Pandas has decided to strip out these square brackets in slice notation. The API has been overridden just as surely as the API has been overridden in the path lib and redefining how the slash works. So let's switch from grabbing some rows to grabbing the equivalent columns. We just move that 3 and that 6 over to the other side. Now you're grabbing columns by numeric index. It takes a while to wrap your mind around. It is not easy to do. Now say we wanted the intersection of those rows and columns. And this is the power that they're going after. We're taking a little slicer wedge from out in the middle of their 3 to 6 here, 3 to 6 here, and that square intersection that has 57 in the upper left. Crisscross eyes. 57 in the upper left and 5 in the lower right there. And so that's pretty much it. I wanted to share that with you because that goes right hand in hand with this video that I just shot. So you have now a driving video and a talking head video on this same wonderful topic of overriding APIs and the explicitness of knowing that you have different APIs based on, context. That's not the context. That's the context. Import pandas as PD. df equals pd.dataframe of the table. And if you need to reassure yourself of the context, you're using a method of an object, and you can always check what type of thing that object is. It's pandas data frame. You could probably even check the methods of the objects. It's the index location indexer. So thanks for joining me. Hope to see you again soon, and I hope that was very useful to you. And if you thought so, thumbs up that video, subscribe, and spread the word.